All right, so cut off. I'll do part B right now. Hopefully got the other one, but either way, we'll have the final result when we're done. All right, so we have two lines here. We could say a couple ways to name this vertical line here. AC or CA would do it. So we'll say line AC is perfectly fine. And then another line that also would be part of this would be this horizontal line here. So again, there's 3 points on that line. We could say, BC is fine, line BC. And then, of course, we could pick any 2 points. Like even AE would technically be a line, right? We could name line AE. So there's a lot of different ways. Even if they're not drawn and we have 2 points, we can always make a line. 2 points are always form a line or can have a line between them. All right, so then we have 2 planes we want to name. Well, we have plane N and plane F. Okay. And then we want to name a point that's on line BD. Well, if it's on line BD, I mean, it could be either B, it could be D, or it could be something between them or even outside of them. So we could say also C. So there's one of those options. C is probably your best bet there. Okay, so draw and label each of the following. A segment with endpoints M and N. So we have M, N as another endpoint. There we go. Array with endpoint F that passes through G. All right, endpoint F passes through point G. Okay, we're going to name this a line that contains A and C. All right, well, that would just be line A. And we could always just say line AC, of course. You could also say line AB in this case, right? A plane that contains points A, D, and C. So this is really only one plane here. So we should probably get to do some harder ones tomorrow, but that one's fine for now. All right, so let's go down here, and we'll maybe get here. All right, so let's name the intersection of TV and US. Well, TV and US intersect only at this one point here. So that would be point U. The intersection of ray US, which is here, and plane R. Well, it only intersects in one spot, and that's also point U. And then the intersection of segment TU and segment UV, there's only one place where they overlap, and again, that's point U. All right, cool. Tell whether each of the following is sometimes, always, or never true. Support your answer. If 2 planes intersect, they intersect in a straight line. Right? If 2 planes intersect, that's always true. If they intersect, right? They don't always have to intersect, but if they do, they will be in a straight line. If two lines intersect, they intersect at 2 different points. Actually, that would be never. If 2 lines intersect, they intersect at a single point. AB is another name for line AB is another name for line AB. That's always going to be true. And then that's just how we name them. And then if 2 rays share a common endpoint, then they form a line. Well, they could, right? In other words, we have an example here where if I had these 2 rays, right, this one going this way and this one going this way, share a common endpoint, they could form a line. But you could also share a common endpoint and sort of not form a line. So it's true here, but not true here. So it's basically going to be, the answer is sometimes, right? Sometimes true. All right, so which of the following, oops, that's fine. Which of the following is a set of non-collinear points? So in this case, we're looking for points that are non-collinear. So it's going to be P, Q, R, right? Those are not collinear points. So we would say C. What's the greatest number of intersection points for 4 coplanar lines can have? So let's check this out. We can go 1 coplanar line. We'll say sort of 2 coplanar lines. And then I'm going to try to make the most intersections. So I'll make sort of another one here that makes 3 coplanar lines. And I could actually have, it looks like another line going across here. So let's count these points of intersection here. I'll draw them red. We have sort of 1, 2, 3, 4, 5, 6 points of intersection. So that looks like the most we're going to get, and it's actually the biggest answer. So that works out for me. Okay, so these are certain postulates. We can look these up based on the worksheet. I really wanted to get to the critical thinking one before it runs out. So it says, is it possible to draw 3 points that are non-coplanar? So we actually know this answer here, right? It's impossible. to draw 3 points that are non-coplanar. 3 points are always going to be coplanar. If 3 points happen to be in the same line, collinear as well. We couldn't name the plane using those 3 points, but they still would be coplanar. There's no possible way that these 3 points that I couldn't make sort of a plane that kind of goes through them. You can sort of, there will be a plane that can go sort of through each of these points. It is not, right? Not possible. No would be our answer, I guess, if you want to answer it grammatically correct. So hope that helped, and that's good.